Okay, I'm going to hit this again, same packet. I'm just going to do some of the ones we didn't do. So if I need to write that as an exponent, 4 takes the denominator, 5 is the numerator. 24 to the power of 5 fourths. Okay, right here. 5 goes in the denominator because the index, and then 35 to the 2/5 power. 45, 3, 4/3. And we'll save these for later. Okay, multiplication. Okay, as you know, to multiply radicals, we need a 1 and a 2 and a 3. Okay, so first move is to multiply the outer factors, 12, and the inner factors, 5 times 250. It's 1,250. Okay. Okay, second step is to divide into that by your perfect force. Now, you're on this list. You got to be on the right list, Sparky. So divide by 625. Whoops. Bingo. So I drop my 12 factor, and then I split this into two separate factors of radical or fourth roots. So 625 in the first root, 2 in the second. You're going to get all muzzled up if you reverse the 2, okay? Because this goes away, and that's 5. And then I can quite clearly see we're going to be multiplying 12 by 5. Well, that's 60 with a fourth root of 2. Boom. Okay, I'm going to do this one. Same idea. 5 times 2 is 10. With a 3. Then I take 8 times 24. 192. Okay, try to divide into your 192 perfect cubes. So divide it by 25. 125 doesn't work. Boom. Okay. So I drop my factor of 10. 64, 3. Okay, this does not become 8. It's a cubed root. It's 4. Okay, because 8 times 8 times 8 is not 64, but that is. So 40 with a cubed root of 3. Okay, we'll save that for a rainy day. Okay, now we're going to be adding our roots together. Okay, so again, you can't add anything until the numbers, that number there and that number there, are the same. Right now they're not, so we can't add anything. You don't add the outers and the inners. That's like a multiplication. I have a lot of people who do that, and that's about 5 points off the assessment if you do that crap. Okay, so I'm on fourths. 32 divides by 16, it's 2, so 7. So again, what I say, 16 works and 2. Don't replace that with 4. Okay, the fourth root of 16 is 2. So 7 multiplied by 2 is 14 with a fourth root of 2. Okay, then 6. Okay, 1,250. I see what I can divide by. Have to be 625. Yep, it does. So I drop my 6 like it's hot. I can't forget about the 6. Okay, and then 625 and 2. Okay, you replace the 625 with its equivalent value, which is 5. And then 6 times 5 is 30. And I end up with fourth root of 2. So mission accomplished. I got the numbers under the roots to be the same of 2. So keep it at 2. You did it. You got them the same for a reason. And then we add the outer coefficients, and that's 44. Okay, I'm going to do this one. So again, another adding. Now, if you don't see a number in the index, it's perfect squares, square roots. Okay, they don't put 2's there. Now, here's an interesting deal. 2 is not going to divide by anything other than 1, so that's prime. You ain't breaking that down. So because it's stupid to divide by 1, it's just the same thing. Now, 98's not prime. Okay, better not be. So 98 divided by 81. 98 divided by 64. No. Divided by 49, you bet. So 49 and 2 in that order. So I drop my 3. I'm going to write with this, works a little better. So 49 and 2. Okay, that becomes 7. 3 times 7 is 21 with its square root of 2. Okay, so mission accomplished. We have a root. You don't need to put a 2 in the index, and you ended up with 2 inside. And that allows the Herminator here to add the coefficients, 27 square root of 2. Okay, now right here, you're simplifying a radical that includes variables. So let's give each factor its own radical. By the way, if you're really good, there's a way to do this in your head, okay? Because like 48 is divisible by 16 is 3. So I'd have 4 outside, 3 inside, then you group them mentally. But that's not for everybody in here. I'm trying to reach my whole clientele. Okay, 48 again, I said divides by 16, and you get 3. So get rid of your 16, because that actually is 4, because it's a square root. So 4's kicked out, 3's still in. 1, 2, 3, 4, 5. You don't see the number in the index, you group them by 2's. You got 2 full groups, 1 left over. Again, if you can do the variables in your head, you can. There's 3 with none left over. Okay, I'm going to do another one. This time it's a 4. Okay, so I start dividing 405. And I'm on the 4. See, I was on the wrong list. I would have been in trouble. Okay. So 405 divided by 256, decimal. 405 divided by 81 is 5. So I make that, and you divide it by 81, we got 5. Now 81 is replaced with 3. So 3 is outside with a 5 inside. Okay, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Grouping them by 4s. 1, 2. So I got 2 groups with 1 left. Don't put the actual numbers. If there's a number, you put it to raise it to the power. So 4. Okay, 2 full groups, none left over. Bam. Okay, now I will be going on to the next part, okay? Get rid of that negative on that 2. I don't like that. Okay, I got to solve for x. I don't know how many answers there are because x is inside a square root. Now we have to undo the operations outside first. Before I worry about that square root, we need a minus 10. That's 20, so 2 square root 2x plus 5 equals 20. Now, you have a multiplication of 2 to undo by dividing. So the square root of 2x plus 5 equals 10. Okay, now I lift the square root by taking both sides to the second. This is an easy one. It's not like there's a binomial over there. 10 to the second's 100. So 2x plus 5 equals 100. And then I minus 5 to get 95. Divide by 2. Decimal, that's all right. 47.5. Okay, I'm going to do this one down here. Well, here's my square root. There's no operations outside, so I go right to my second power. So that gives me 6x plus 1. 37 to the second, so a huge number. 1,369. Then we minus 1, and that would be 1,368. Some of you guys would do this on your own. You'd think you're doing something wrong, but you're not. Okay. So, and then it's just basic algebra. Once the root's gone on that one, 228. Save that one for a rainy day. Okay, now I'm going to do, these ones are the ones that are not fun. You have a root, there's no operations, but second, and you're like, oh crap, I need to parenthesize that. And that's a binomial. So we have just 2x plus 30. The side that had the square root cancels, And over here I got blank x second plus blank x plus blank. Okay. So I go to a piece of scratch paper, and I need to take x plus 3, because when I square a binomial, it always ends up as a trinomial. Some of you have figured out a way to do that in your head. That's fine. Okay. I don't really care. So 1x times 1x, 1x times, your way's got to work, though, every time, not some of the time. So it's 1x second, 3x, 3x. Those don't cancel. They're both positive. So I got 1, 6, 9. Now, you don't ABC that. You got to move this crap over here, because you don't factor unless it's equal to 0. So I subtract 2x from 6x, and then 30 is subtracted from 9. Okay, so 1x squared plus 4x, and that's negative 21. Okay. Now it's time to factor the trinomial. Okay, GCF. I'll do my T over here. So give myself some room. GCF's 1, so I don't really need that. 1 times negative 21 is negative 21. So we're looking for a difference of positive of 4. 2 is a decimal, 3 and 7, bam. Okay, 4 is positive, so I know to make positive 4, we need positive 7. We have a negative up there with a difference, so the signs go opposite. Okay, your A is a 1, so I don't need to make the 4 parentheses and reduce it. X minus 3, x plus 7 equals 0. So obviously we know there are two answers. So x minus 3 equals 0, x plus 7 equals 0. So I'm going to be adding a 3, and I'm going to be minusing a 7. Bam. Okay, now I'm actually going to do the one on the next page. Again, nothing happened, no operations, so I go to my second power. But again, binomial, that means trouble. Well, not trouble, just a pain in the butt problem. Okay, so again, square binomial. We're going to take x plus 5 times x plus 5, okay? So x times x, x times 5, you can put 1s in front, might be better. Some of you like those 1s there. That's what, nothing wrong with that. That's why I do it. 5 times 1x and 5 times 5. That's 1x second, 5x, 5x, and 25. So blank x squared plus blank x plus blank, so we got 1, 10, 25. Okay. Now, once again, you don't ABC that. Dude, because if you ABC that, you're just going to end up back here. Okay. That doesn't do you any good. You just went backwards. Okay. You need to move this over. So you minus 1, then plus 1x. So you got 1x second plus 11x plus 24 equals 0. Now I need to write that in factored form. There's 3 terms. There would be no greatest common factor. It's 1. Well, there is 1. I just don't do it because that's stupid. 1x is worth doing, but not just 1. Okay, so 1 times positive 24, positive 24. So that's a sum of 11, positive 11. It's 3 and 8. So 11, we got positive 8 and positive 3. So A is 1. And that's F1, F2. So x plus 3 equals 0. X plus 8 equals 0. So I take 3 away. And I take 8 away. I'll save that one for a rainy day. Okay, I'm only going to do one of these on this one. I've already done 2 of them. Okay, now this one here, I see a power. So when I see a power, x to the third m. Is x to any other power other than a 3? No, so only. Okay, so the only, if it's odd, I guess I got one answer. Now let's get that x third by itself. 34. Divide by 2, 17. And we need to find what times what times what's 17. Well, it's an irrational number, so you're going to have to use your calculator. Irrational means it's a decimal that never terminates. So root, you got to put a 3 in the index. You can't do a square root to get rid of a third power. So I go 3 second caret 17, and I got 2.57. Save that one. Okay, I'll do this one here, and I'll do this one. Okay, so again, I see power, but the power belongs to the parentheses with 2x plus 12 to the fourth. Well, I should bring in q then. There's two answers, okay, because it's even, but I want to simplify the equation, get the parentheses out of there, and then I got a way. I'm just manipulating it. Okay, so 2x plus 12. 2x plus 12. Because that looks very intimidating at the beginning. Okay, so if I get rid of the parentheses, just replace it with a variable. Well, I know how to do this. That's 50. And then I find the fourth root of each side, not the square root. I go 4 second caret 50. 2.66 or 65, I don't care. Or negative 2.66. So we need to minus 12, but then we need to divide by 2. Okay, so I take 2 minus 2.66, or no, 2.66 minus 12, and then I divide that by 2, and that's going to be negative 4.67. Okay. Okay, so negative 2.66 minus 12, then divide by 2, negative 7.33. Didn't give myself a lot of room there. Okay, this bad boy, it's kind of hard when you're only working with two squares. So I see a power, 3 over 2 power, but again, that's to a whole parentheses. So we want to manipulate this so it's much easier. 3's odd, the top number's odd. That's your exponent. The bottom number is just a root, okay? So, one answer. Okay, so let's make our table. I'm not going to need this side, though. And q, 3q to the 3 over 2 power. Once again, if that's an odd exponent on top, you don't do the right side. I'm going to mark you off if you do. That's 81. Then divide by 3. That's 27. So we have q to the power of 3 over 2 equals 27. Now again, you're going to reciprocate that, not draw a root. Okay, 2/3, 2/3. So I take 27 to the power of 2/3, and I get 9. Okay, nice round number. Now, and then you bring back your 5x plus 2. Now you're like, how is that 9? Well, you got to understand, if you find the cubed root at 27, what times what's 27, that's 3. But then raised to the second power is 9, okay, for those of you that want a deeper understanding. Assuming you may not care, and that's fine. That's your right. But if you want a deep understanding as to how that's 9, you take the cubed root, because a 3 means a cubed root. And again, the cubed root of 27 is 3, but then the 2 raises the 3 to the second power. That's 9. And then 7 divided by 5 is 1.4. Okay, I'm not doing that one. I can't even see it. Okay, now I do want to multiply the i's, so I take 2 times 2. 2 times negative 2i. 2i times 2. 2i times negative 2i, and that's 4. Negative 4i, positive 4i, and that's negative 4i to the second power. Negative 4 times negative 1 is 4, and then 4 plus 4 is 8. Okay, now let's do this one here. So that's just one multiplication. We know 8 times 1 is 8 with I to the second, but then that morphs into negative 1, and that equals negative 8. Okay, now multiplying roots. Again, I want to put a 1 as a coefficient, so I just go 5 to 1. 1 multiplication, 5. I open up a square root and multiply the 3's. You don't leave it that way. The square root of 9 is 3. 5 times 3 is 15. Okay, next one. Again, we'll put 1's there. So again, I got 2 terms here, 2 terms here. That results in a FOIL method because I see the minus and plus operations. So that's FOIL. 3 times 3. 3 times 1 square root of 6. And these are conjugates again, just like those I. Negative 1 square root of 6 times 3. And then negative 1 square root of 6 times positive 1 square root of 6. So that's 9. That's 3 with the square root of 6. It's negative 3 with the square root of 6. Get that out of there. Negative and positive of the same product go away. That's negative 1 square root of 36. Well, again, that ain't simplified because that's 6. Okay? 6 times negative 1 is negative 6. Now add them. 3. I'll do another one. Okay. By the way, let's do this one, but that's supposed to be a minus 4. Put 1's in front. So 1 square root of 6 times 1 square root of 6. Remember to connect the square root of 6 to the 1. 1 with its square root of 6 times negative 4. Then 4 times 1 with its square root of 6. And 4 times negative 4. No square roots involved there. 1 times 1, 1. Square root, 6 times 6, 36. Delete that because that's a 6. That equals 6. 1 times negative 4 is negative 4 with a square root of 6. But 4 times 1 is 4 with its square root of 6. Cancel them. And then negative 16. So I add 6 and negative 16, and that's negative 10. Okay, graphing. That's a parentheses. Get rid of it. Okay. All right. Again, I said, there's no asymptote when it's in a square root. Totally different ballgame. Asymptotes are exponential functions where the x is an exponent. Here it's just in a square root. So again, it makes sense to start with perfect squares. By the way, if it's a cube root, you go 1/827, but I don't usually put those on tests. And also, cube root, the negatives don't give you a domain error. The domain's unrestricted. Now again, you really think I want this 9 here and take 9 plus 6. Okay, I'm glad I started with 9, but 9 plus 6 is 15. 15 ain't a perfect square. That's going to be some sloppy decimal. So I undo the plus 9 by plus 6 by minusing 6. You don't add 6 either. You're just making the problem worse by adding, okay? It's like you're solving an equation. Don't write this down. But it's like, I don't want that plus 6 there. What would I do? Well, I wouldn't add it. I'd minus it. Well, same different here when I'm trying to manipulate a graph. That's 3. That's negative 2. And you're like, well, that's going to be a domain error. No, it's not, because negative 2 plus 6 is 4, okay, in the square root. Trust the process. Negative 10, negative 15. Okay, now we want to block that middle off, okay. Okay, now let's plug that in. It's just a square root, so don't mess with the caret key. Just go negative 2, second, and then the x squared, and then 3 plus 6. You're like, well, this doesn't seem as confusing. That's because I explained it like an idiot the first time. So that's negative 3. You get a negative output, okay? That's perfectly okay. Because you're multiplying by negative 2. It's probably quite possible. Okay, when we go negative, we got to reset it. Negative 2 times second. Then up there. And then negative 2 plus 6. Close it. And then add your 3. Negative 1. Let's put in negative 5. Positive 1. Guessing that's 3. Now let's see if we get a domain error. Sure do. Okay. Remember, you have to graph the middle first. That's because that tells you where the arrow goes. So left 1, 2, 3, 4, 5, 6. 1, 2, 3. Stop. I don't care the direction it swings. We're not going past that. Negative 5, 1. 1, 2, 3, 4, 5, up 1. Negative 2, negative 1. And then 3, negative 3. And we can keep going that way forever. Okay, I'll do one more graph. Again, same idea. No asymptote, okay? Don't worry about that. Remember, that could mark the stopping point, depending on if I get domain, which I know I do. It's a square root. I don't want a plus 4 there. Minus 4. Negative 5. And I'm not talking a lot because you can easily see what I'm doing. Okay, and away we go. So I go 3. Second. Square root. And then 5 plus 4. And then minus 6. Okay, that's 3. Okay, putting a 0 in for 5 will give me a 0, I guess. Let me do that in my head a second. Yeah, I would, because 0 plus 4 is 4. Square root of 4 is 2 times 3 is 6. Minus 6 is 0. Okay, so 3. And then negative 3, and then second. Because now I got to put negatives in. And then negative 4 plus 4. And then subtract 6, and you get negative 6. Wait a second, that made no sense. Yeah, because I didn't put in the right number. Negative 3. So that's probably going to be negative 6. Now, if I put negatives in, yeah, I know, because at that point, negative 5 plus 4 is it's a negative in the square root. So that's an error. Remember, that's first. So left 4, down 1, 2, 3, 4, 5, 6. Stop. Negative 3, negative 3. 0, 0. 5, 3. There you go.